All right. Thank you all for having us. So I'm Nick Kephart. I run the product management team at ThousandEyes. So I'm going to talk a little bit about how our customers use the product. What are some of the use cases that that you might think about as you are trying to tackle some of the problems that that Alex was mentioning in the previous session, and also go into some demos. So we're going to have very, very few slides here, and this will be almost all demos. So it should be a lot of fun. So with that, we're going to get started. So the major idea here is that there's a lot of change going on with networking. That's all happening at once. That's what drives and animates a lot of what we build and what we focus on from a product perspective and in terms of solving problems for our customers. So this includes network architectures broadly. So you've all been hearing about changes to wide area networks, but it's happening in lots of different elements of networking within the data center, and also quite dramatically within cloud environments as well. We'll even see some of that in the demos. Service delivery models are changing, increasing use of content delivery networks, even some folks starting to use concepts like edge computing. And in addition to that, users are changing the way that they consume applications, where they're doing it, what devices they're doing it on, what networks they're doing it on. And so all of these make it a lot more difficult to solve the ultimate problem that we want to figure out, which is how good are our services, what's the performance over the network, and how can we make it better over time? And so that's ultimately what we're trying to solve for. So what can network intelligence then do to really benefit some of these changes? So we're going to talk about three key use cases, three ways that you can get more information to solve some hard problems. So the first is digital experience of customers. So most businesses today have some sort of application that you have to deliver, and what does that look like? What does it mean? How can I make sure that people are happy? The second is employees are starting to use software as a service, and then also applications that are hosted in public cloud environments. And the third is hybrid WAN. So starting to change the way that our branch offices and employees are actually connecting to our networks. So we're going to take each one of these individually. I'll kind of describe a little bit about how ThousandEyes can be used to tackle problems in each of these three areas, and we'll do a demo for each one. So that's going to be the agenda for today. All right, so first is customer digital experience. So in this case, I have an application that I really care about. I could be a bank, I could be a software as a service application, I might just have a mobile app or a marketing website. You got something. Almost everyone has something that they care about. And that digital experience relies on a pretty complex chain of events that actually gets that application from an end user to that service being available and useful for them. That could include looking up DNS. That could include some content delivery network in the center of it. That could include a set of carriers and other service providers that connect up all of the networks in between these parts. That can include a hosting environment, maybe my own, maybe someone else's, right? So there's a lot of things that can fail, a lot of pieces and parts that we either have indirect control over or maybe not much control over at all. So how does ThousandEyes help think about this? So we take an approach where we focus on giving a perspective from a broad set of vantage points around the world. We call these our cloud agents. These are essentially just infrastructure you can use as a service. Doesn't require any installation or any hard work on the customer's end. You can just turn it on and start saying, what does it look like from this network or this geography or this part of the world to understand performance to some service I have hosted. Anything in a data center, any cloud environment, any IP address that will have a response, HTTP request. A lot of different services can be supported here. So that's the beauty of it, is it works really broadly. And also the beauty of it is it doesn't really matter what's in between. We'll give you a sense of exactly what a customer would see. So if you've load balanced it around the world, or if you are using Akamai, or if you've decided that everything should come back to your home office and that's where you have a server sitting under your desk, that's exactly what the data will show. So let's take a look at what some of this might look like from an actual perspective in the product. So I'll move over here to an example, and let's see if I can actually get this to show up on the screen here, or if we have our mirroring set up. There we go. It's not going to just be complete swipe here and there, but I'll zoom in slightly here for us. All right, so this is a view of some of the key ThousandEyes interface here. And the idea that we have, maybe if we kind of take a step back first, is in this case, we're looking at, again, I own some application. In this case, let's say I own a collaboration application. I am actually the GoToMeeting service here, is the specific application we're looking at. And I want to collect some information about how users are experiencing my GoToMeeting service. So we're looking at, if we look here on the target URL here on the left-hand side, this is actually the place you go to sign in, and it assigns you out to which services GoToMeeting is going to connect you up to as a client. And we're looking at a number of different views here on the left-hand side, and you'll see this replicated throughout some of the demos we're going to go through today of various layers, you can think of it, of the application delivery. So this is everything from what does the health of the HTTP connection look like down through elements of the network stack that are related to that HTTP connection. So it's tying together a bunch of different components to actually understand this delivery chain. And so in this case, in the HTTP availability, response time, throughput sets of metrics, we're going to see information related to what does the health of a web service look like? We can see that over time. In this case, we've selected a period of time here. We can see what that availability looks like. If it's not 100%, I'd be a little bit concerned, because that means there's people around the world, as depicted here on this map, so some various places around the world we can see that we're actually doing monitoring from, that are unable to reach my service. I can see those in red right there on the map. I can even see very easily demonstrated right here, what are some of those problems? So are people able to look up my domain name? Looks like yes. Are people able to connect to my server or service? Answer is no for some of those folks. But the health of the application actually looks pretty decent here. So this is the sort of thing that you can actually pull together a bunch of information to understand what goes on in terms of this delivery chain. All right, so we have a point in time where some folks in Europe are not able to reach my services as GoToMeeting at this particular point. I can actually, in addition to some of those metrics, I can actually change the perspective. So move from a web layer to maybe a network layer. So rather than looking at web metrics, I can look at things like loss and latency and jitter. I can look at bandwidth, other key pieces of information, and I can change these around, right? So I can kind of move in context, and it's going to be able to show me different sets of information here. In this particular case, what looks to be happening is at that same time when I'm seeing problems in reaching my service, and I saw some of those connection failures, well, I'm also seeing a lot of loss on the network. And in particular, on that map, I see from some of those same familiar places, if I move to just a different representation of that data here, I can see that there's a set of locations around the world, in this case, all in Europe, that are seeing complete loss, so unable to make a connection, and everyone else looks pretty good, right? So I've already started to understand what's the scope of my problem. Looks like it's isolated to some locations in Europe. Don't quite yet know what's going wrong. But we have a few more tools at the ready to help us understand that. And in all of these parts or all these different failure modes, there's a lot of different places you can dig in. If DNS was failing, we have some tools to help you really figure that out. If the application is failing, you can dig into maybe what's going on the website or other dependent objects that make up your service. So if we move down to what Alex was talking about, our path visualization, this is a layer 3 representation of the connections of all of those points we saw on the map to our service. So again, we're looking at loss here as the context. So I'm going to move down here. And this is going to look like a pretty big jumble of things, so I'll explain it at the moment. But this gives you a sense of how any given connection from, in this case, let's say, Paris, France. So that's there on the left-hand side. Those are the actual monitoring locations that we have instrumented. In this case, they're just provided by ThousandEyes. Would access our service. In this case, that is the GoToMeeting service there on the right-hand side. So that's at this point, Citrix Online, though that's kind of changed hands over time. So they still have the same AS name, but in California. And in this case, this is actually being hosted out of a SwitchNAP data center, which we'll actually see if we kind of zoom back a little bit in there. You're going to see pretty quickly that this is being hosted likely somewhere on the West Coast. So the idea here is each one of these circles represents a layer 3 interface. And this is looking at kind of any perspective. It could be a service provider, this could be your own network, and right away we can see with some of these red circles here, those were the 4 locations that we saw problems happening. I can immediately see that they actually all converge in a common point that's in a specific service provider. Looks like a link, perhaps a transatlantic link between Amsterdam and New York here, and WV fiber, so a specific AS that we're traversing between Europe, and in this case, the GoToMeeting service that's hosted in the United States. And I can all of a sudden do some interesting things here. I can figure out, what does this look like over time? So I can see this is the current paths that we're taking across the internet right now. I could go in and reverse this, kind of do more like a DVR style and figure out, well, what did this look like before? I can immediately see it actually looks pretty similar. We see a lot of the same interfaces represented, but at previous time periods when I wasn't having a problem, I actually continued on through that network further along. So there's actually some problem here that's going on in this network that's preventing this connection from happening.
Just a quick question.
Absolutely.
How long will it take if something changes in this path until you have this visualization? The question.
Sure. So, and maybe this is kind of worth going into a little bit. So all of this is user configurable in terms of how you want to actually sample this data out. So in this case, this is what we call a scheduled test. You set it to a schedule that you can determine. I believe in this particular example, we're looking at every 5 minutes, but you could bring that down to every minute if you wanted, and different elements of the data set you can also tweak. So the routing data you could kind of tweak to a different level of fidelity versus the path trace data here that we see versus some of the higher level data of maybe actually sampling the application performance.
And just a quick second question. How long can you store the history so that you can look back?
Absolutely. So right now, this is saved for 30 days. So this high fidelity data, we save the aggregate information for 90 days. And then at any point, you can actually go and persist this data if you want. So if you wanted to say, I have an interesting set of information, I saw some outage or a performance issue, or I just want to benchmark or baseline something, I can go and save and persist a chunk of several days worth of data, and we'll save it forever. So you have a few different options there. You can some of our customers will also then pull this data raw out through the API and actually store it themselves. So a few different options depending on what you want.
Okay, great.
Is this just traceroute data?
So this is going to be doing a combination of trace routes and pings and other active types of probing through the network and collecting as much information as possible. We're going to be presenting all sorts of additional data in terms of the loss and latency. We're going to be trying to figure out MPLS information. You'll see a little bit later how we can also look at quality of service remarkings through the network. But each of these, we'll try and pull out as much possible information as we can get without you owning any segments of the network.
Have you seen any issues where service providers will mark down or bottom of the barrel, traceroute traffic? Does that show false positives or anything like that for you?
It is possible. So in some portions of certain networks, you'll see what we would show in here as just blank circles, which is going to be the equivalent of a star on a trace route. So in those cases, there might be some interface that's not responding. In general, that doesn't happen in most networks, but there may be some portions of particular cloud provider networks where deep inside the data center, they may not respond to anything. So
not so much respond, more of just you'll have an ultra high latency whenever you do like a trace route through a provider.
Yeah, understood. So that certainly will happen. What we do is we take a look at minimum latency. So we try and take a look at and understand what's the shortest period of time it takes to get between any of these two interfaces to try and reduce the problems that you'll get with ICMP responses being queued up. And we'll also actually analyze the difference between some of these to help understand things like whether geolocation is right and other information related to, in this case, what would be like a delay on a specific link. In this case, you can see some very short period of time, but in some cases that'll be much longer. In this case, this is a trans-Pacific link here it would look like, but yeah, that's certainly possible. And there will be a certain number of false positives or negatives that are possible. You can configure how many samples we take here if you want higher or low fidelity information.
I just wanted to add one thing. So this is not, we don't use vanilla trace routes. We actually craft our own packets. And there's a lot of stuff happening here in the background. So we have algorithms to infer what we call forwarding loss, which is pretty non-trivial because there's cases of interfaces that never reply to with ICMP time exceeded, and cases where they sometimes don't reply because of loss. So we distinguish those two cases to determine when there's actually loss going on.
So you'll see Ricardo a little bit later. He's our CTO, who's built a lot of the underpinnings of this. You can certainly grill him a lot more on a bunch of these elements. But yeah, the idea here is that we're using a lot of tricks of both active monitoring, and you'll also see some additional polling that we do to combine as much information as possible and get it as high fidelity as possible. So we compare this all to routing information, to reverse DNS, to as many different sources to clean it up for you.
Thank you.
All right, so that's the basic concept here. We could kind of see what that problem was. We'll also pull additional layers of information, like in this case, we'll pull BGP routing information, so you can compare it in and understand what's going on. So at this particular time where we were seeing issues, we actually saw changes in a routing topology. This is now looking at the control plane rather than the data plane. So this is looking at BGP and how it's routing traffic around the internet. And so for that given prefix, so we're constantly looking at which prefixes are actually being advertised out for a given service. We can see that normally. This is what this all looks like. This is the Citrix Online autonomous system. We see two of their service providers. It looks like Cogent, and then also a SwitchSnap ASN here. And then if I go back up and I look at what's happening at this similar time period, we can actually see there's some specific things going on. So I'm going to simplify this down to just some of the routing monitors that actually saw changes and only show those. So we can see those here. You can also expand and contract all of these views in various ways. But we can see in this particular visualization, again, this is where all the traffic is destined to. This looks like a pretty messy example, but it'll give you a sense of what's going on. This is that one suspect autonomous system there, WV Fiber, that was actually dropping all the traffic in New York that was causing our problem for our European customers. And we can see there with the dotted red lines, this actually means that they dropped their peering with a bunch of important networks that actually we care about. So St. Petersburg, Russia was one of the places that was impacted. Other sorts of European carriers are impacted there. So in this case, you can actually understand a little bit more of what's going on with some of your service providers, some of your carriers. In this case, this is a peer of a peer. And so you might have some ability to actually influence this, or you may at least know this is going to be my root cause analysis. This is going to be the status page update that I have to set up for my customers, right? So the concept here is depending on the failure that you're seeing and where it is, you have a lot of information to be able to take action on it in whatever way is possible.
This is really important for SD-WAN, because if you're using public WAN, or as you call it, internet, you need to know if 4 hops away from you there's some sort of brownout, and maybe that's why your backbone isn't working, why your SD-WAN's not working. You know that you're getting loss because you're getting reports from the SD-WAN platform you bought that something's going wrong. The question is where, and then you can start beating up your telco to actually do something about it. You can give them data and harass them and then get a refund.
Exactly, right? There's multiple things here. There's, first up is you might actually know about the outage before anyone's posted anything about it. We see that pretty frequently. Usually, most of these carriers and service providers are not the most forthcoming in being timely about reporting issues. So that's the first thing, which can, in minutes matter here. The second thing is you might actually be able to provide them some information that can help them actually more rapidly solve the problem. We've certainly seen multiple cases of that. And then lastly, even if all of those fail and you're still kind of stuck with whatever service you've got, you might at least have some ammunition when you're having a business conversation with them about how well did that service really go over the last month or year, and how happy are we with it. And this, you can save these types of events and information so that you have a record here that's pretty obvious of this is what I saw from my environment, or this is what my users saw from these locations around the world.
Yes, it's the network. No, it's not me.
Yeah, exactly. It might be the network, but it's not necessarily your network.
Yeah, but when it comes down to salary reviews, yes, it's the network. No, it's not me. I want my payroll. That's the important part.
We can't always promise that. Sometimes it will be your problem.
Yeah, well, at least you know where the problem is.
Yeah.
If all the SD-WAN's looking green, but you go into ThousandEyes, you can see that somewhere in the internet there's something wrong. Then you can go to the people and say, yes, there's something wrong. It's it's in the middle of the backbone in such and such, and there's nothing we can do.
Yep.
I have just a question. It's a use case that I see here. If somebody tries to inject an route in the BGP, and just to reroute your traffic to some location,
Yes.
this could also be helpful to see that actually that somebody is rerouting your AS or something on your path.
Yeah, I'll defer a little bit of that conversation to Ricardo, who's going to tackle some of those concepts, but certainly things like hijacks, leaks, DDoS mitigation, all sorts of other scenarios where either you're changing DNS or you're changing routing, or someone else is doing it and you don't know, can be captured, and you can validate those scenarios here. But yeah, we would see in a route leak, you'd be able to see is someone else advertising my ASN, or maybe someone's just injected themselves into a path that's been picked up by certain carriers around the internet.
Yeah, it is like your traffic is still flowing, maybe a little bit additional latency,
Yep.
but it's still working, so you don't get any tickets from, I don't know, from users or things like that. And here you can at least see that.
But it's being observed by someone, yeah. And the nice thing about this is you'd be able to then compare this back to the layer 3 information. You could actually see, okay, a routing change happened. Did I also see a concurrent change in the actual paths that traffic took? And what did that look like? We've seen in some cases where there were route leaks that involved certain Eastern European countries that, took traffic for a ride, 60 hops through random service providers. It's certainly possible.
That's important to point out too, because that's not easy information to obtain unless you have access to carrier network route tables, right? There's very few ways to see real-time route changes like that, especially in a hijack sense.
Yeah, it's pretty difficult to figure out. So Ricardo's going to talk about a little bit of some of the upcoming work and the stuff that we're doing right now related to not just so you can dig through this information, but we can actually show it to you that's actually happened. So a few other notes on this topic. I'll maybe move this one out of our way here. Let's see if I can go back to our presentation here. So just a couple of notes on what's happened, what have we been up to, and how does this all work. So as I mentioned before, this is, you actually configure tests and you decide the data sampling, the monitoring you want. So we've introduced new, more frequent tests over the last few months, so folks can, choose if you have a really critical service and you want to really understand what's going on there, to pull it as frequently as possible, and also to trigger alerts very rapidly. We've done a lot of work to support IPv6, which a lot of the major cloud and consumer carriers are using increasingly. So you can use our monitoring vantage points both for IPv4 or IPv6, and the routing feeds would also support that as well. And then a bunch of new locations that we support to do this, which is just the hands-free monitoring from anywhere that you want. 37 new locations around global metros around the world. So that's kind of this general idea. I'll touch upon a couple of others and kind of move rapidly through this since well, the fun thing here is we get to do demos, so you get to see it all, but I want to make sure we leave some time for everyone else. So another key use case. So what if your employees are using a SaaS provider? Well, we have options there to actually monitor not just from general locations around the internet, but actually from specific points within your network. So we call two different types of agents. So these are the enterprise and endpoint agents, and they can be delivered across a number of different vantage points. This can be a Linux box, a micro appliance, a Docker container. You can throw it on a virtual machine. It runs, the endpoint agent itself will run on just what you would expect, a Mac or Windows device. And we'll actually pick up some real user experience too. So you can combine both active testing of information along with real user experience to really understand how are people experiencing my services. And I can do all sorts of things like planning out what a deployment might look like for a new cloud service, tracking SLAs against it, and troubleshooting performance over time. And this would work against kind of any set of software as a service applications. We have customers monitoring all of the ones listed there on the right-hand side. And you can do file transfer tests and voice tests and some of the other things that will also come up a little bit later in today's presentation. So with that, what I'm going to do is move back to my browser here and see if I can reacquire where my mouse is. It's real fun to do demos on the side here. All right, let's jump over to, I'll just, in this case, we'll simplify things to keep it moving along. This is kind of just a different view. So rather than digging into the really nitty-gritty details of how all this works, you can also take it up a level. So let's say you maybe have some, your boss or some pesky executive or project manager has some things that they really care about, and we get this all the time. I don't understand what all this information means. What's BGP, blah, blah, like all this stuff. That's great. So there's a lot of folks that are not going to understand all this stuff. How can you kind of roll this all up into something that's a lot more understandable for someone? So I'll zoom in here a little bit more again. And the idea would be, this is actually testing against Office 365, a set of applications. So we're looking at the top here. This is availability, like an SLA of various Office 365 applications. Outlook Web Access, SharePoint Online, OneNote, Word, can support a lot of different types of applications from, again, various points around the world. In this case, different offices. So we've placed enterprise agents or endpoint agents on actual employee devices to be able to sample this information. And you can create lots of nice dashboards with an understanding of what does this look like over the last month or the last day or the last hour, and be able to really get rich information. All of this is easy to customize. And so you can build not just really tactical troubleshooting related workflows, but also more executive or reporting or SLA workflows. And you can customize this in all sorts of ways. We can see right away that response times to South Africa here are problematic. The other thing I'd mention here in the maps, which is an interesting one that relates to just generally about how cloud-based services work, is look at the difference between Outlook Web Access and SharePoint Online. Those two, this is the same time period of data, the same locations. This is response time. Looks very different, right? And the reason for that is the way that Microsoft delivers these two applications is very different, right? Outlook Web Access comes from a Microsoft CDN, so you're going to the closest Microsoft POP. And in that case, you'd say, well, maybe they need one in South Africa and the Middle East, but the rest of the world's looking pretty good. SharePoint Online, in this case, usually comes back to one instance, right, that you have globally around the world where all of your resources are being held. And in this case, that instance is maybe not optimized for our users in Asia and Latin America and Africa, right? So you get these types of insights that you can really pull out, and you can know, okay, maybe I screwed up a deployment or performance wasn't what I expected. I can go and try and figure out how do we fix this. Or alternatively, if I think ahead, I might actually be able to anticipate some of the ways that network engineers are going to be blamed for all of these problems that are going on with this cloud deployment, right? And so this is, I think some of the interesting things is that these cloud services are not all built the same. They are not architected the same, and the performance should not be expected to be the same, even from a similar vendor, right? Even what would be called one suite of applications is really, different applications that are all combined together.
So ultimately, though, you mentioned that it's more than traceroute.
Yeah.
Because when I first heard that word, immediately I thought to myself, some ISPs are going to try to dump your traffic as quickly as possible, like a CDN,
Yep.
As close to the customer as possible. Some are going to try to get it out of their network because they're not making any money on it. How do you account for like maybe asymmetric routing on a global scale? If it's in like a region, like just in the Northeast US, I'm going to stay within, one carrier, a couple carriers, and it sort of stays the same, but that's not necessarily the case. And, maybe even instances of ECMP within a carrier network somewhere.
Yes.
So if I'm taking a benchmark of my company, I can do that. So hopefully it's predictable and static, right?
Yep.
If it's designed well. That's not necessarily the case on a large public internet scale, public WAN scale, right? How do I take a benchmark when yesterday it was this, and then 2 days later I'm taking different paths by design?
Yeah, and I mean part of that is you want to know that, right? This information is actually going to be populated by individual end users. So in this case, we can even use a user as they use a service will actually draw out these paths and figure out what's going on. So in that case, we're going to be seeing exactly where did they connect to, and we'll find all sorts of issues. Maybe the geo load balancing is not set up properly, or we're misassociating where someone actually is around the world to the proper point of presence. Or maybe someone just changed up how they've architected this service. We've seen all of these things. And the idea will be, yes, this will change over time, but that's exactly what you probably need to see to be able to understand what's happening, because that's what's happening to your users. Ideally, this won't change every day, but we definitely see that this happens. We use a bunch of these services ourselves, and we've seen our data centers have moved, in different parts of the country, in the U.S. at least, and that's changed performance, impacts. We've also seen problems with, we're a Cogent customer, and we can't use IPv6 to Google from our offices, for instance. There's those sorts of things that are the reality, and you'll see them in the data.
No, that's the use case. It's the real-time visibility on a day-to-day operations basis. Obviously, with the some semblance of benchmarking and a historical perspective, but ultimately, that's how I see a real practical use case for a large enterprise that has presence in multiple continents. Is real-time troubleshooting. What's going on?
Absolutely, right. And this could be for your payment services in your retail stores. If you're a bank and you have transactions, this might be the case. Or this could be some other maybe more rudimentary set of services that you care about that's worth monitoring, and you want to know the real-time performance.
So is there anything that we can do beyond looking at the layer 3 hops? Now, obviously, internally, you can look at a lot more information about devices down to like what interface and what's going on.
Yep.
Is there anything that we can do beyond just the name of a device out in somewhere that you can track?
Absolutely. So
some I see here.
I think we're gonna talk about that in a second, but maybe what I'll do is I'll give you a little bit of a hint of what you'll see related to this use case, because I think this is where it is important, right? We'll see some of the cases where we can actually enrich this data a little bit more. So some of the things that have been going on related to this, which is how do I understand the performance from my employees, is you can deploy on a broader set of now networking gear, in addition to maybe plain vanilla servers and virtual machines and other types of devices, to actually get some of these vantage points. So we support now a range of Cisco and Juniper CPEs that can actually support things like Docker or KVM, or all sorts of onboard environments that aren't just additional blades that can be added. Can look at SIP, voice services, file transfer, kind of a wide range of enterprise services you care about. And one thing that we're going to be seeing, which is probably very much to this point, is we can actually help enrich that level of information a little bit more if we know the context of your own network. And so one of the presentations that will be coming up in a few minutes is going to be on what we call device layer. So rather than just seeing these, there's an interface here, we can actually associate it back down to the performance of an actual device in your network, should you be able to actually have the credentials to look at that.
When you're looking at response time, is that just the initial setting up of the connection to that service, like Office 365, or are you also doing tests throughout to measure the performance of the entire session that the user is, like if I'm updating a SharePoint doc or, working on an Office document?
Sure. So there's maybe kind of 3 steps here that I could. So the simplest one is you can test against a specific endpoint, like let's say a server or a service, and we'll give you the breakdown of like how long did it take to look up DNS and connect and all of that goodness. Second one is you can actually build a more complex transaction. So let's say to get to SharePoint, I actually needed to go through my SSO service. We can actually do more of a scripted transaction where sign me in through a username and password and go through a set of steps, look at how long did each of those take, and those may have been all different endpoints, maybe even all different service providers that provided that entire experience, right? And then the third piece from the endpoint agents, which I'll show in just a moment here, is data from the individual end user, in which case I can actually see their performance for their actual session. And I would see things like, we're sending data back and forth of when every time you click a new comment in that SharePoint document. And it'll be a long-running set of data that will run over hours as long as the user is using that session. So you have a different, a variety of different ways that you can look at this depending on what you really want, what problems you want to solve. We definitely say for benchmarking and digging through lots of information, focusing on some of the endpoint agent data, which helps you really have comparable information, is very good. But if you want to be able to troubleshoot an individual end user, what you probably want is some of the endpoint data. So I can show that in just a second here.
Yeah, and one more, if you don't mind.
Yeah.
So if I'm looking at data over a session, is there a way to intuit, because you're not instrumenting the Microsoft side, what's some kind of internal latency maybe in their software stack versus network latency? Can you distinguish between what might be causing a delay in a
We could tell you what the user is experiencing there. So if we're sitting around waiting for the server to respond, we'll know that, right? If we're sitting around waiting for the server to respond, we won't necessarily know why. We won't know, oh, they're having some database problem, or their storage array went down, or the data
say
center.
this is a server delay, not a network hop delay.
Exactly. You would be able to say a simple thing, which is this an application failure or is this a network failure? And some of the ones we've been looking at, these were network failures, but in many cases, you'll see there's no loss, there's no latency, paths haven't changed, routing hasn't changed, but the service is degraded, and you can very clearly say, oh, this is not our problem as a network team. Maybe we need to hand this off to a different team to actually go triage this. We need to hand it back to the service provider to say, this is definitely you guys.
It does always seem to come back to making sure people don't think it's the network. Like, it really does. It's just another way to prove it's not.
Because the challenge here is always at the network, we don't know. We can't actually instantly say it's not the network without necessarily lying. Mm-hmm. And the only way you can do that is to have some sort of visibility and analytics engines monitoring the system for you to make you look smart.
Well, hopefully it makes you actually smart.
The other thing,
No, my goal isn't to be smart, it's actually just to look smart. Being smart is completely optional.
Yeah.
Pay rises are only given on your ability to look smart,
Right.
not to be smart. You need to understand these differences, Phil.
I get my pay raises on good looks and witty charm, but
Well, that's fair, I can see, yes.
one of the things that I think that this does that, like I said before, is difficult for most folks to obtain information on, is it gives you a abstracted visibility into the things that happen on the, at the WAN scale that, like, most enterprise folks aren't going to think about or even really maybe even know exist, like turning up and down peerings at exchange points, and maybe a unrelated peering comes up in the same type of environment and causes a resource constraint because it's using more than it's using more bandwidth than it's been allocated or whatever.
Yep.
And so giving the end user visibility into those black boxes that they're probably not thinking about at all is that's a troubleshooting and triage game changer, really, for businesses that don't run the wide area network.
Yeah, for a long time it's been easy to really focus on the micro scale, but a lot of these services require also more of a macro scale view in this case to figure out what's going on, because there's just too many pieces and parts all changing at once.
One of the frequent things that service providers, having built a lot of them, that one of the frequent things that gets said is, look, we can't control the network that's outside of our management domain, right? The customer calls and complains and says, this service, my bandwidth stinks, or however they phrase it, right?
Yeah.
We can only say, well, I can show you everything that I have visibility into, but then if they have something like this, that support call doesn't even happen, right? Because they can go in and they can look and they can see, well, up through the service provider that I'm paying, everything looks fine, but when I get there, which is outside of their control, then I have problems. So then, you could potentially remove the need for that first level support call to the service provider and go directly to where the problem is, shortening your troubleshooting time.
Yeah, I mean, a lot of these things are hard to know, and as you go and also architect new solutions, figure out, should I get a direct peering link to AWS? Right. Should I, what are some of the options I might have? This can help understand, well, what does it look like today? What might it look like in the future? Or can I even test what that should look like in the interim to decide, is it worth my money, given the performance change that might happen?
I have one question regarding to combined data, yeah?
Okay.
So for example, one of our famous cloud provider has a particular problem in one facility, let's say in America, yeah? Mm-hmm. Can you combine this data so you will see that from a lot of customer using your environment that there is a particular problem? Do you somehow share that information, or is it, let's say, for every installation they have to measure this data individually?
So right now, all of these data sets here that you're seeing are individual in here. But what we do also show is the context, and and this is something Ricardo in a session in a couple of minutes we'll get into, is we also collect this data and aggregate and understand what's the performance of overall things like content delivery network performance, DNS performance, software as a service performance, and also carrier performance at an aggregate level. So we also combine this in ways that we can provide back some information there. There's some pieces of that are already in here, and he's going to describe what some of those look like. But yeah, that's exactly the point. Is the nice thing about having this on a SaaS platform, which I don't know if we've really touched so much, but should be obvious here that I'm using a browser and it's working from this hotel. Is that yeah, you can actually benefit from all the other folks that are sampling information in our customer base are also looking at a lot of the same things you care about, and they can also provide a really interesting, rich perspective. You're not going to see all of their data, you're not going to see what their office architectures look like, but you'll see if they're having problems through the same providers at the same geographies.
Yeah, I think especially with cloud offerings, this is something that then experience the majority of customers using that cloud provider. Yeah.
Absolutely.
Yeah, cool.
All right.
I really agree with Greg here, because really for posterity, for the viewers that are going to watch this video in the future and everything, because I think we all know this already, and we talked about it in the car, there's a lot of technology that we like to talk about that sometimes, and again, we were discussing this earlier, we don't always necessarily see, becoming very prevalent in the enterprise quickly. And so we're talking about it and we don't see it in our daily jobs. But even the smallest enterprises out there with, a few hundred users are using SD-WAN, are using cloud services. And so visibility becomes extremely paramount more and more. So, you can, every single segment of the market, every vertical, from a 500-person law firm to, a global organization. So I think, because I know you guys have been around for a while, I've seen your presentations before.
Yep.
So yeah, visibility, I get it. But the use case is becoming more and more compelling every day in a broader segment of the market, in my opinion. So.
Yeah, the idea is to skate to the puck, which we know all these changes are happening and they're not slowing down. So that's the idea. So what I'm going to talk about then maybe last is a little bit of this end user experience that I've been alluding to. So in this case, it's a similar type of use case, but instead of maybe accessing cloud services, I can also look at performance across an internal network and even local area network problems to resolve all sorts of issues that might be happening that really trouble me, like, is this wireless access point working properly? Is my local DNS server working properly? Some of the things that maybe sound mundane in a cloud world, but all of these things get jumbled up and users don't know the difference of what's going wrong. They're going to still report some sort of issue. So let's take a look at what that might look like here. And we'll finish up this session so we make sure you can see some of all the cool additional things. If I can constantly remember where my mouse is, we'll be good. All right, so let's take a look at endpoint agent data. So in this particular case, I'm going to look at some information. This is a totally different view. This is actually end user data. So I mentioned that you can sample information from Mac and Windows endpoints. And in addition to just standard like, run a test every few minutes to this service, you can actually collect data that's useful in helping to troubleshoot a particular issue. So let's take a look at something here like connection failures, which I might care about. So there's a bunch of different options here around loss and latency, some of the things you've seen before. Also, page success rates, stuff that matters to an end user. We can see information. This is from a few days ago. This is me right here. This is me within our office. You can see our office network. I'm accessing Google Docs at this particular time. You can actually go see what document I was working on at that time. We also have, one of my colleagues who was in the office as well was accessing a Microsoft service here and was having some issues in our network. This is actually a user session that you could see from this point in time during the day when he was on the network. Here's some of his information about his actual device here. He's using Google Chrome on a MacBook Air. He's accessing this through our Wi-Fi environment. There's our SSID. You can even see the base station he's connected to. You can see the wireless quality is maybe not all that we want for our wireless performance in our office. The gateway here is really terrible. That's going to prevent almost anything of use if it takes a half second to get to the internet gateway in our office. And we can actually see on the right-hand side here, he wasn't even actually able to get to his Outlook environment here because of a DNS error, interestingly. Okay, so that's kind of, so what's going on here? How can we understand from that macro level we've been talking about all the way down to this micro level? We can see some interesting things. So first off, I can go up here, in addition to our network block that I've already filtered this on, I have a lot of different options of being able to analyze data. So I can look through here for a particular agent. This is going to be a bunch of the folks in the office. This is Pradnik who's having the issue here. And this is his information. These are his sessions in this time period that we've recorded. In addition to that, I can see what does his network connectivity look like at this time. So this is not just from a static place. This is wherever he is. So I can actually see he's in the ThousandEyes network there. I could even group this by his specific location. That's him there in the San Francisco Bay Area. He's on our Wi-Fi network, accessing both a Google service, and this is the actual connectivity that he goes through. He goes through, it looks like San Jose, to access Google, what you might expect. This is our office in San Francisco, going through Cogent, as I mentioned before. And here's this totally failed connection to Microsoft because we weren't even able to do the DNS lookup. Okay, so that's interesting, but there's actually some more information I can get here. I can actually look at the local network topology of where he's been and understand again, what he's doing, and even any proxies or VPNs he's using. In this case, this is our local DNS server that he's accessing. I could go and see, what does that look like for him? What's our domain resolution time look like? We can see, wow, that's pretty terrible, 3 seconds to resolve a domain. No wonder we're having problems here. So if I were the IT admin getting this case where Prab's saying, look, I can't access my Outlook inbox, what's going on, I'd be like, I know this isn't even a problem with Outlook. This isn't a problem, maybe with the network connectivity. This is some problem either between our access point and that specific DNS server, or maybe the DNS server is having a problem here. I could also even zoom out from that and say, well, are other people being impacted from this? I can again group by those agents and see. This is colored by the domain resolution time. Well, he's the only one being impacted, unfortunately. Well, good or bad news. And lots of other people are using that same DNS server, and they're not having problems. I can also see there's people in my environment that maybe, based on my corporate policies, I do or don't want using like a public DNS server, as an example. I can see all sorts of things. Who's using my guest network as well? So all sorts of interesting information that you can use from a security perspective to be able to troubleshoot local area network problems, and also translate those back to these wide area and internet scale network problems. So gives you some sense of kind of the breadth of a lot of the things going on. This is a product that we introduced about 1.5 years ago, and is being deployed particularly in cases with remote workers and employees, and then also very common in wireless office contexts. As you can imagine, wireless is usually one of those constant pain points. So with that, I'm going to wrap this up so I can make sure we have time for everyone else and leave you with kind of the latest things there that we've done, really around, we've added, support for DNS, enhanced support for proxies. We mentioned Zscaler before, so if you're using a web-based proxy, you can see the path all the way through there. And then any VPN, so if you're using enterprise or personal VPNs and all of the problems associated with that from folks remote or on-site, we can actually plot all of those out. And you'll see what's going on, who's using what, is something misconfigured, lots of important uses of this information. Any questions before I break?
I have one question. You
Sure.
mentioned the security aspect, yeah? You have shown that you also can see what file was uploaded, for example, to Google Docs, yeah?
Yep.
Are customers using this for data leakage protection? So they're seeing one guy was fired on his last day. He uploaded 1,000 documents, yeah, something like that?
Right now, no. So we don't, this is more from a network and internet security perspective that this would be relevant. Certainly the data can be used in that way, and certainly you could take it out into another system, like dump it into Splunk or some other correlation databases you might be using to do that. Security has not been a domain we've focused on, simply because it's complex enough and it really is not kind of our DNA as an organization. But a lot of the data collected here could be used in very interesting ways for compliance or security related purposes. So I'd say It's possible, but probably today our customers have to do a bit of the legwork to actually get the value out of the data.
So speaking of that legwork, how available is that data? Can it be programmatically accessed via an API or something like that?
Sure. So all the data that you'll see today and all the demos that you'll see, the raw data is available via the API. The reporting data, the aggregations that I showed you, those dashboards are available via the API. And then there's also an alert or event stream that's available via the API. So 3 types of data that you can pull out that's all broadly available.
How frequent is the stream? Is it literally like a streaming telemetry?
We have webhooks and kind of general API support there. Okay. We use a streaming model as part of our architecture. Right now, we don't offer just a pure stream out to customers. Okay. But yeah, you could have a webhook and we'll push the data whenever we get new data points in that are interesting for that. Yep.
So coming back to the Google Doc very briefly, where are you getting the name of the doc from?
So in this case, we're actually, so these endpoint agents can be deployed on end user devices, and you can control exactly what type of information you want to collect. I want to collect information when a user's in my office network and they're accessing these specific domains. And so we're going to collect that both off the OS layer as well as out of the browser itself.
So are you effectively putting extensions in the browser to be able to pull that out as well?
Yes. So an optional item here is to have the browser extension that will pull the browser session data, and then the OS level data and some of that network topology stuff that you saw is from the OS layer.
All right.
Makes
sense?
It's
nice to know where you get inside the SSL. So.
Absolutely, yeah. So yeah, exactly. I mean, that's the idea here is that we basically are just reading off whatever the user is seeing, and so you have complete control over what you think is appropriate and not. And one reason we built it this way was we make an IT admin opt in to every single domain that they want to monitor for the purpose of you probably don't want to know all the stuff that people are doing. So just monitor what you really care to see or what you care to be audited for.
But if you want to see it, he is not connected, for example, to the corporate network, to his home DSL line.
Exactly.
You can still stream that to the ThousandEyes.
Yeah, exactly.
But that requires agents or access to data.
Yes, so that would require...
You would require the proxy server to be streaming data to you about objects accessed, or an agent in the router that's able to intercept.
So right now, these do not require any agents that sit on any of these. These are all observed from the client side. So if you have...
taken from the packet flow.
Yep.
Right.
Exactly. This is taking a look at which connections is the OS making, what's the browser doing, those sorts of things.
One more quick one, and I'm sorry, I don't want to. With regard to the DNS thing where the DNS query failed, if I were already monitoring the DNS servers from a client perspective and there was a reason why it had failed and you'd found out what it was, does that get linked in? In other words, is there any, can I follow the ball, right? I see that this guy failed that because his DNS lookup failed. Why did his DNS lookup fail? Well, I still don't know right now. I'm wondering how I join the dots there, or if that's...
Yeah, so right now we would leave you there. We also offer a set of testing against DNS, so you could be doing that too. And some of that is still places that we have to work on to connect all the dots. So there's lots of interesting data here, and there's still lots of relationships that I think we haven't explored in addition to what we've done.
All right, thank you.
Sound good? All right, thank you all. I'm going to make time for our next presentation, which is going to be all about devices.